Okay, the table above me shows the heights and weights of a group of girls. Our outcome is to find the equation for the least squares regression line of best fit, or sometimes called the line of best fit. That's what we're after, and we're going to take it in 3 simple, straightforward steps. Number 1, what we're going to do is we're going to work out the means, the mean for the scores up here, the mean for the height, and the mean for the weights of the girls, and their respective standard deviations. So the standard deviation for the height, standard deviation for their weights. Once we work them out, then we're going to go to step number 2, which is to work out the gradient, the slope of this line of best fit. And we're going to use this formula right here. It's m, the gradient, equals r, the correlation coefficient, times on the top the standard deviation for the y variable divided by the standard deviation of the x variables. And then step number 3, we're going to work out the y-intercept, which is b, the y-intercept, equals y, the mean of the y-scores, minus the gradient times the mean of the x-scores. Let's call, well, what can we call? Let's call the height x and the weight y. The height is x and the weight y. So let me just write it down here. Height is equal to x, and the weight, we'll call it y. So we can work with both of them because we're all familiar with this format, y equals mx plus b, and then we'll change it back into height and weight. That way it's easy to follow. So let's go for step number 1. We're going to do some calculations. We're going to use the calculator. I'm going to walk you through it step by step. And what we want to find is the means, the mean of each variable, the variables of the height and the weight, and the standard deviations of each one. So that's step number 1. Let's go ahead and do that. Now the good news about this least squares regression line is that we don't do it by eye. It's more accurate, more precise doing it this way, because what it does is it minimizes the average deviations between the line and the data points. So let's use the calculator now. Let's go through it. The first thing I want to do is find the mean for the x scores. Let's call it the height. So all we have to do is turn it on and go mode, and then press 2 for statistics, number 2. And then you've got 2 columns. On the top right, there's a number 2, press 2. That's the A plus BX, press 2. And then you've got 2 columns, X on the left, Y on the right, X on the top, Y down below there. So we're just going to enter each value. So for the first X1, it's 162. So press 162 and then press equals. 167 equals 179 equals 162 equals 149 equals 154 equals 144 equals 157 equals 172 equals 160 equals. Okay, now we get the big blue button up the top and we move the cursor to the right, so just tap it on the right and then scroll up until you get number 1 on the left. Scrolling up. Okay, number 1, we can enter the first score for the weight, which is here, which is the y values. 74 equals 65 equals 87 equals 54 equals 53 equals 61 equals 57 equals 71 equals 79 equals, and finally 58 equals. Now the next thing you do is you press AC, the orange button, AC, clear it. And then we go to shift, top left blue button up the top, shift 1, and we're looking for number, we want to get the correlation coefficient first actually. We're looking for number 5. So press 5, and that's REG. And then we press number 3, which is R, number 3. Press 3 and then press equals. And that'll give us the value for the correlation coefficient. That happens to be R equals 0.7824, to 2 decimal places, I'll round it up, 0.78 will do. There's our correlation coefficient. Okay, then you press AC. Press AC, that clears it. Now go to the blue button up the top left, shift 1, and then press 4 for variance, 4, and then pick number 2, which is the X mean, number 2. And then press equals, and that gives us the X mean scores, which happens to be 160.6. 160.6. Okay, now we press AC and clear it, and then go Shift 1 and then 4 again for variance. And this time we're looking for the standard deviation for x, number 3. Sigma x 3, okay, press 3 and then equals. That's 9.9. 9.90 actually, to 2 decimal places. Okay, let's go over to the, whoops, that's 9.90 over here. 9.90 right there. That's the standard deviation we just worked out. Okay, let's go to the y value. Let's go AC, clear it. Let's press Shift 1, 4 again, variance, and press number 5 for this, the mean of the y-scores. 5, and press equals, and 65.9. 65.9. Okay, now let's clear AC, Shift 1, variance 4, and press number 6 for the standard deviation of y, then press equals again, and that's 10.876, and that rounds up to 10.88 to the decimal places. So we have the mean for the x's, mean for the y's, standard deviation x's, standard deviation y's, and we have R, the correlation coefficient. Now that we have all of those, now we can start putting those values into the step number 2 so we can get and work out the gradient, the slope right over here. So let's work with that now. So our M gradient is equal to R, the correlation coefficient, which is 0.78. Let's put that in there. Drag it right here. 0.78. And then we multiply by, I like to put brackets here, top and bottom. On the top, standard deviation of the y-scores. Standard deviation of the y-scores is 10.88. All over the standard deviation of the x-scores. Standard deviation of x-scores is 9.90. So let's put that all in our calculator. Note the correlation coefficient is positive. So M, the slope, equals 0.78 times bracket 10.88 divided by 9.9, close bracket. Altogether, what that gives us is a gradient of 0.857, rounds up to M equals 0.86. That's our gradient, 0.86. Okay, that's step number 2. Let's go to step number 3. We want to work out the y-intercept. Okay, for the y-intercept, let me just put a little boundary there. So B equals the y-intercept, the mean for the y-scores minus gradient times the mean for the x-scores. So B equals, the mean for the y-scores is 65.9. 65.9. Take away the gradient, which is 0.86. Put that in brackets actually, 0.86 times x, the mean for the x-scores, which is 160.6. Okay, so multiplied by 160.6. It's a decimal there, close bracket. Okay, let's put that in our calculator. So B, the y-intercept, is equal to 65.9 minus bracket 0.86 times 160.6, close bracket. Altogether, the y-intercept equals B equals, it's going to be a negative, it's negative 72.22. There we go. So we have our y-intercept. So they're the key ones. We got M, 0.86, the gradient, and B, the y-intercept, negative 72.22. Let's drag and drop them into the equation. That'll give us the least squares regression line of best fit equation. Okay, let's work this out now. So let's keep it in y and x mode for the now. So y is equal to M, which is 0.86, 0.86 x minus 72.22. Okay, now let's swap it. Now we know the y values is going to be the weight. That's going to be weight for y values, and the x values is going to be height. X values is height. So let's write it down in terms of weight and height using those variables. So W weight is equal to 0.86 h the height minus 72.22. And there you go. That is the equation for the least scores regression line of best fit. W, weight, equals 0.86 h minus 72.22. With that, you can draw a pretty accurate, reasonably precise line of best fit on any number plane. Hope that helps. Thanks for watching.